Hello folks, well it is Friday and I will get on with the next repair. This is from an end user. As you know, we don't do many end user jobs, but this is for an end user and he has had stuff done before. So what we're going to do is the usual thing. He has supplied the original mic with it, with instructions not to repair that if it's faulty. So we're going to do it on our standard replacement mic. Although this is wired Cybernet, these Maxon built radios are also wired Cybernet, one of these Midland Precision series. So that's a bit of a confusion because normally the Maxon sets would have the 5-pin DIN. So, same chassis as the Maxcom 4E, Comtron, is it CB40, and the Colt 295, Colt 295A, Cobra 21X FM. So it's all the same innards. There's another, isn't there? There's the Sertel, and it goes on. So this is manufactured February 82, so chances are it's got the adjustable S meter, which the earlier version hasn't. And the faux power on behalf of Midland was there is not high-low power on these, which made it, they couldn't be used as a base station if the error was above 7 meters at the time, because they couldn't do low power. Anyway, that was Plustronics who were the importers. So that's all written down and noted. So what we're going to do, we'll power it up using one of the Powleys Mr. Chippy makes, which we sell on eBay, and these are a bit more tonker than what came with the sets. So we'll borrow one of Mr. Chippy's power leads. We do also have these sockets available, and this is all original stuff. It's not it's currently made. These were bought in parts when Maxon built these back in 1981, and they're still current. So they're not patent parts, they are the real thing, and that's good. So we'll plug the extension speaker, which goes into the test equipment, into the extension speaker socket, and we'll plug the extension speaker mounted on the wall into the public address socket. Plug the mic in. I've booked to tune 2 pipe organs this afternoon, which take a couple of hours each. So I've got an eye on the time, and switch picture in picture on. Switch the radio on. 13.8 volts is come on 19. And we'll go straight into what the power meter has to say. So we'll start off on the 3-watt scale. Wow. It does 3.95 watts. On channel 1 does 3.8 watts, and on channel 40, sorry, that was channel 40, 3.8 watts, and on channel 1 it does 4 watts. So I may be able to balance that better. I think if we looked at the service manual, it's probably rated at 3.8 watts anyway. We can't do low power because it doesn't have it, and the transmit current on channel 20 is 1.023 amps, which is jolly good for that kind of power output. We'll have a look at the deviation, but we'll take it with a pinch of salt because the deviation meter can be intermittent on this test set. We'll then pass it across to the machine behind. Wow, it's reached 2.2 on this test set. We don't do the VCO on these because you have to add an extra 4 components in. Manufacturer assembles these using a pin jig and does the tests without putting 4 of the components in, thus cutting costs or increasing their profit, one or the other. Let's go on to the frequency counter. The radio should be on 27.79125. We're on 27.79062, so it does need to come up a bit. We'll Test equipment's been on half an hour, so it's not far off, you know, the absolute being spot on. Right, so we'll put that same frequency into the signal generator, so we're testing the receiver in a fair way. Got exactly the same frequency in there that we have on transmit. We don't have any receive at all. Oh, tell you what a fool! I put 7.6, 7.9. I'm looking for. That's better, isn't it? Oh, that's a bit. RF gain's down. I'm going to say that was a bit as deaf as a post. So you can switch your RF gain out on these sets. So switch it to DX. So really anything under 1 microvolt for this chassis is okay. It's not exactly Banatone 5-star. I did once do a York 861 for this customer, which is one of those 1 in 1,000 exceptional ones where you get the receive sensitivity at like 0.2 microvolts. Let's see what we've got. 0.9, so it's in spec. For 10 dB, it's 0.85. And for 20 dB it is 1.15. So let's go to full squelch, and on the signal generator, I'm not showing you, I should have been showing you the sine diameter, but there you go. I'll go over to the attenuator. I did press the button, but you know what it's like. Pressed the button on my record player and it stayed on 33 when I was playing a 45, and I was recording that, and then of course you've got to erase it and but I had pressed the button. 100 microvolts is when I would like the squelch to open. It doesn't, but it does open at 2.2 millivolts, which is really far too harsh. Let's turn the squelch down on the radio, put the signal generator to standby and park it at 0.3 of a microvolt. Set the squelch on the radio to threshold. That's threshold. Signal generator back on. It's coming in at 0.7, which is excellent. So the S meter in the UK should read 100 microvolts for S9, and it reads very low, but it may not be adjustable, but I think this one is. It's actually set for 3 millivolts, which is ridiculous. You tend to find they're oversensitive, like 25 microvolts. Don't confuse this figure with amateur radio, in which case it's 50 microvolts. Meter works. Check PA. Testing 1 2, testing 1 2. Where on PA switch, but working okay. Potentiometers are fine, sockets are fine, PA function's fine. I haven't tried the internal speaker, and we just need to look at the RF meter. So when I key up, we know the radio is doing just about 4 watts. And what does it do? It swings across to, well, it swings across to 5. So it needs to just pop down a fraction to be in line with what the set's doing. As I've said before, they're a relative power meter, and they only read true when they're on a dummy load. So we calibrate it on a dummy load, but when you put it on an aerial, it may read 1 when you transmit, it may swing across. If the radio is doing 4 watts, it's still doing 4 watts because the meter is relative. Newer radios, they've now got pre-programmed meters, and the manufacturer decides that they're going to read whatever, and whether it's transmitting or not, they still read whatever, and I think that's fake. But there you go. It's much cheaper to do that than put a real sensor in to see what the RF's doing. Must cost all of a pound out that. But you multiply that, you know, and it makes a difference. Especially if they're coming out of the factory for a £5. At least these are repairable, unless they've had the kiss of death. So just unsoldered the speaker, but I haven't switched the soldering iron on. I'm going to switch the test equipment on behind me, so that's going to be ready to do the deviation test. So let's look at the figures. The transmitter's about as it should be. It's slightly off frequency, not illegally, but starting to be noticeably off frequency by the time we get under 0.075. And I'd like to be able to bring up the receiver a little bit, but that is in spec, and I'd like to be able to correct the S meter somewhat. So don't know where the deviation is at this stage, but we'll find out pretty shortly. So the VSO would be there. We'd have to put extra parts in. We're not going to do that, and there's no reason to mess with it. It doesn't look like it has been messed with. So pop that speaker off. Genuine Maxon speaker in a genuine Maxon set. I wonder if Midland ever made anything, or whether they've always just bought stuff in. I mean, certainly since CB was in the UK in 1981, it's just a bought-in brand, isn't it? But I expect a lot of the others are. I mean, Harvard, they got the 420M, fantastic set. They got the Good Buddy, which is dreary. Right. Let's go into transmit. Let's just see if we can balance this a bit better and still maintain a 4 watt output. Don't like to see all these sealed, especially not that one, because I can't put my soldering iron in that one. It's polythene. We're looking for the centre. I'm not even showing you. We're looking for the centre of the peak. That's a little bit out. Be very careful not to touch the sides of these and damage the coils. That was a little bit out. Can't do that. I've got to hope this is soft enough to get the tool in. I think they've used beeswax, and that's the right thing. Well, power's not now 4 watts. It's dropped a bit, but it's balanced. Well, I'm assuming it is. Now it's about 3.85. quite there. Now, just looking at that coil there, placement of these airspace coils is critical. And we've all seen the coil stretcher. Trouble is you end up with harmonics. So it's now 3.9 watts. Let's see what it is on channel 1. It's 3.9 watts, and on channel 40 it's 3.8 watts. But it's balanced, and you often find that because it's easier to achieve the lower frequencies, you often find sets doing a little bit more power on channel 1 than they do on channel 40. Now we'll come back to this when it's cold, but that's what I've written down, because the before figures are actually when it's cold, but these are when it's hot but tuned. So really, if I was going to be super fair, I'd actually wait half an hour and then retest this. But I'll tell you that further on in the thing. But that's what I write down on the list. That's when it's been transmitting for 10 minutes. So that's a good result, and let's adjust the meter. That's saying 5. It's meter presets the back one. These are silver plated on these, which you're not going to get that quality today. That's a bit dirty. So we'll just waggle that about. So I'd hate to replace one of these presets, because what I'd put in wouldn't be as good a quality. Yeah, that's fine. That's 4. Right. We'll do deviation, so I'll go to the test set behind me. And we'll see what it has to say. Wow, it's virtually spot on. It could be just that tiny bit high. I don't want it to break up on other sets, so just get that right. Wow, that's 32. Sometimes dreaders have been in a household where they smoke, and it takes its toll on the presets. Wallow. Wallow. There we go. So now we'll see what the Marconi test set says. Well, it says exactly the same, so it's possible that the test set isn't lying today. We had 2.2, didn't we? So it's probably about there. 2.2 to 2.5 peak. You can see that 1, 2, 1, 2, wallow, 1, 2, 1, and then a big wallow. We just about get 2.5. Right, so transmit current is now 1.867 amps. So as we've brought up the power, we've balanced it a little bit, and it has come up, even though it looks like it's come down. But the interference has come down. Yes, put it on frequency. That sounds like good. And see whether it will go. Let's hope so. 2779064. I really need to be over 100 to let it out. It's not going to go. No, I've got Duff reference crystal. That's a shame. They're getting hard to come by, and getting new ones never work. Alright, well, we'll carry on with the tune-up. So now what we'll do is set the signal generator to what I've now set the radio to, which was 092. 2779092. Just like that. So I'm sure most of you understand there's a single crystal as a reference oscillator for the synthesizer, which generates all the channels. So if that's off frequency on transmit, it's off frequency exactly the same on receive. So if I tune the radio on receive with its off frequency, as soon as I change the crystal, tune it for the correct frequency, the whole radio will be on frequency. Just in case you think I'm a bit bonkers, which you probably do anyway. Right, let's look at how the detector is on this radio. So we've got 100 microvolts on the signal generator. We'll have a look at the oscilloscope. So we've got an S9 equivalent signal. And detectors down there, hiding. How on earth do we get to that? As it was absolutely spot on, and on the Maxon chassis it's one of the things that can shift, so that's good. Right, we'll go to the cyanide meter. Just move the camera across because the mice will have moved it overnight. If I had a cat and didn't have the mice, well, the cat would probably move it. So we'll take that to about... Do you know what? It sounds a bit IF-y. I'm going to do the IF first. We don't normally. It just sounds a bit out. Yeah, that's a vast improvement. Yeah. Right, well, we'll go back to where we were starting with the receive front end. There's the door. Well, that was the post with some stuff. There's a repair amongst those. Can I just mention, anyone sending repairs in, don't ask for post requiring a signature. I'm basically 8 miles from Grantham. They only come out 3 days a week to us, and if we're not in, it goes back to the sorting office, but it can go all the way back to Nottingham, 35 miles away. So then you think, oh my goodness, what's going to happen now? So it's just a thing, because we're not always going to be around, and being in the middle of nowhere, there isn't a security problem, and we've got cameras for cameras. Anyway, where were we? Let's just think if we can get a little bit more out of this. Tell you what, that was spot on, that one. Fraction there. Now we're going to go back to these IF ones. I think that's as good as we're going to get. Now I think this is one of those sets that if you touch it, it gets better. Right, so when I was doing the original thingy, I did have my hand on the case, and I'll put my hand on the case for the next test. So we now have what? For 12 dB, we now have 0.76. So it has come up a bit. For 10 dB, 0.7, and for 20 dB, it's now 0.95. So that's nice to have that under 1. It's not often they do go under 1 as well on this chassis, so that's good. So it would have sounded, I think the best way to describe it, it would have sounded funny. It really would. Not so much difference with the sensitivity, but it just would have sounded funny with the IF being out. Right, usually that affects the squelch, but the squelch was working great. So let's do the S meter. So without having made any adjustments to the S meter, we've still got it quite low. And on these sets, the S meter, when the adjustment is fitted, it's going to be there. And that one's dirty as well. So there we have S9 now at the 100 microvolts. So that's sorted. That just leaves us with squelch. So, as I said, if we turn the squelch to full, I've got the test set at 100 microvolts, and I would expect this squelch to, oops, wrong one, still the wrong one. Let's go through all the cameras, find the right one. So I've got 100 microvolts on. So what we're going to do is adjust the squelch preset until the squelch opens. So, just to be sure, we've got the squelch on full, with 100 microvolts on the signal generator. So hopefully, when I drop the signal generator, the squelch will come in and open at 100, which it is doing. That's exactly where I want it. So, having done that, we'll turn the squelch down on the radio, turn the signal generator to standby, turn the squelch to the threshold, and then switch the signal generator back on with it parked at 0.3. So, see what it is now. It's 0.65. It was already fine at 0.7, but it's that little bit more sensitive now. 0.65 microvolts and 100 microvolts for it to be on full. So, we've now done probably about 20 minutes since I did the transmitter. So just let's see what it's doing, just out of interest, because I always jot these down as hot figures, and I might casually say what the cold figure is. That's still I can't work the camera remote today. So 5 watts is here on the meter, and 4 watts is there. So I'm going to keep that there. Let's just key up and see what we've got. It's still 3.9, so that's not changed. So at what point does this radio become 4 watts? I shouldn't do this with custom sets, but our car, the Leaf, when it's running, it's 14.4 volts. And because these don't have a regulated power rail for the transmitter it is affected. So if this was in our car, I'll tell you what, we'll drop it. We'll take it at 0.2 to 14. There we go. It's going to transmit. It's now 3.95, 14 point. Oh, I've gone out of it. 14.1 is now 4 watts. So in our car, it'd be doing a full 4 watts. But it makes no difference anyway. By the time you've got to 3.6, left alone 3.8 and 3.9. I've done these demonstrations till the cows come home. But some people have got this power thing. If we put this on a hobby meter, it's probably doing about 7 watts. If I'd got a hobby meter, I'd show you, but trouble is we take these things out and about and they don't end up back here. Right. Oh, we've got to do the frequency. So I'll just go into frequency again and let's see whether there has been any change. It was 8.2, wasn't it? 9.2 or something. 9.4, 9.495. I can't let that out. So now this customer sent us quite a lot of scrap over the years. So the thing to do for him is to find something he sent and recover a crystal out of it. And hopefully we can that way sort him out without him having to pay for a part. So I'll do that behind the scenes. It looks dark. I've only got the bench light on. I've just taken a crystal out of a set which he has given us 4 spares. So I would think that this is going to be about right. Yeah, we're about there. Look, 79106. I could let it go at that. We might be able to just bring it up a bit. There we go. 79126. That's very satisfactory. You know what? Now when I'm looking at scrap AM sets, you know, from pre-1981, nearly all the crystals are knackered. Replace ref X-tool recovered from scrap set donated by you. That solves that problem then, doesn't it? So before I put the lid on this, let's just see what the power's doing. I know we've already proved it'll do 4 watts at 14 volts. Let's see what it's doing at 13.8 now it's cold. And the answer is, it's 4.2 watts from cold. So there you go, folks. Right, I'll come back to that. We've got some dry joints. I just did a couple of dry joints. It's had some work, probably been reverse polarity or something at some time, and I just want to clean up with isopropyl alcohol, so that'll need to dry for half an hour, and then that's a set done. We do have other sets we're going to be looking at. I think there's a Thunderpole T1000, and I think there's a Lafayette set of the type I've never seen before, which is probably only just not a current model. It's a multi-norm like the Thunderbolt T1000 is. So there's some attractions. I think the Lafayette will be next if that's what's been sent in. I don't always open boxes. So I'll go and do this and we'll wait for the alcohol to dry. I'll probably go and have my tea or something. Bearing in mind I'm from Yorkshire originally, so it's breakfast, dinner, tea. Dinner's what you do at 12 noon, tea's what you do at 5:30. Right, I'll come back in a bit. Okay, so I've put it back together now, and I need to put some more case screws in. Put 2 in. Oops, can't even do that. We were at Nottingham yesterday. We went to go and pick up a broken record player I bought on eBay, and he's going to the pub, and it was near Nottingham, and I really should have taken the camcorder. We could have done a road trip to Nottingham, and then you could have heard all the burner brigade at full whack at close proximity. Well, Nana Roger. Right, well that's that. We did tune a couple of organs this afternoon, so I've come back 3 hours later, and the radio's spot on frequency now, and the radio's also doing, it's doing full 4 watts when cold, on 13.8 volts, so job's a good one. So that can go out to the customer. I've got another one to do from him, but we've got some in between. So thank you for watching Midland 3001. From 1982.